What are contact forces and what are non-contact forces?
Contact forces is like is the force that has to act on the object.
Okay.
So like we have to make contact with the object so that the object will move, will change in place. So that is like a contact force.
What about non-contact forces?
Non-contact forces is like gravity. It's not like nothing contact to the object, but still there is like a force act on the object.
Yeah. So when you mention contact and non-contact, I agree. Like if the two objects touches each other, right? If there's some contact between them. But when you say that for the non-contact forces, could the force act on the object as well?
Could the object act on the force?
Or could the force act on the object?
Yeah.
Yeah. So it's to act on the object, right?
Yeah.
And if you try to like draw a forces, is it a vector quantity or a scalar quantity?
A force?
Yeah.
A force, it's a vector.
Why is
Yeah,
the
it's
vector?
because it needs a direction, like
Mm-hmm.
going up, down, left, right.
Mm-hmm. It show a direction. So for example, if we have a object and we just represent it by a point like this,
Okay.
and as if that on the mass will concentrate on one point. So
Right.
which is like a mass point or point mass. So if you have a force act on the object, you will just like draw a line with a directions as a vector on that object, right?
Right.
So even if it's a non-contact forces like gravity, it still have an acting point and the force will act on it. And like for gravity, it should be a downward direction, right?
Okay. That's
So
true.
what I'm trying to say that for the forces is a vector direction. So it should have some direction. And with that direction, we should have that the tail of it would be at where? Where's the tail of the force
The
vector?
tail of the force should be on the object.
Yes, that's right. Okay. And this is the key thing that would be the objects here. And for the contact forces and different kind of forces, they will have specific position for the tail, right?
Yeah.
It will depends on different kind of forces. That's just one thing I want to add here, that it will always act on the object.
It will always act on the object.
Just that with like direct contact or like non-direct. Okay.
Alright.
I'll let you continue the mind map then.
Um, so so maybe there are like I can give examples.
Yes, example. Oh, and do you want to add the focus here and note here that force is vector
Um,
and components of a vector?
components about vector.
What properties of a vector that we need to mention?
So it will have with direction.
Very good. Direction. And with direction, then we got the head and the tail.
Yeah. Direction. So heads and tail.
And what's the
Tail.
tail where? That's very good.
What else?
Is there any important about a vector? Not just direction.
Importance about vector.
Yeah.
It's about vector. Maybe the
How do you draw a vector?
with like an arrow on top.
An arrow? Is it difference if the arrow short or long?
It doesn't matter.
Are you sure? Like if you want to demonstrate a 5 Newton force vector and
So it's gonna be, yeah, it depends on like how big the force is.
You remember the keyword to demonstrate how big a vector is? What is the term for it?
The term for it.
Right,
The magnitude. The
yep,
magnitude.
that's right. That's right.
So what should we? So the magnitude.
And you remember when we try to solve for the math, sometimes we will have the value can be negative and positive, right?
Yeah.
So how can we know when it should be positive and when it should be negative?
Negative, it's like it's going the opposite direction
Opposite direction of what?
of the motion, like
Yeah.
of the motion direction.
Yeah. Usually we assign for the motion direction to be the positive one. So if you have something against not opposite to the positive direction, it should be negative. That's it. But sometimes you can also like choose any direction to be the positive. Okay.
Okay.
Yeah, it depends on how you choose the positive direction. But usually we choose the motion direction because it makes sense.
All right.
Okay. Okay.
So doing magnitudes, so it's gonna have two more. So it can be like this. Positive means going with the motion direction. So negative means going against motion direction.
But like if you say so, when pay attention here, if you say so, you have like assume that the motion direction to be the positive.
Yeah.
Yeah. So like sometimes, like if someone take the motion direction to be the negative, it's okay. You know,
Okay.
it's just that if we have the motion direction to be positive, so I would say that you add another plus sign after motion direction, so you know that motion direction is the positive direction. So let's add another plus here.
Another plus.
Yeah. So we know that motion direction here is the positive. Okay.
Okay.
And
Okay.
actually, I want to correct this. The magnitude here, magnitude always greater than 0,
Always greater than 0.
because that would be the length, you know?
Okay.
And like a geometrical length, it's always
Geometrical length.
like greater than 0, right? Like for example, if you draw a line like this line will always be a positive value, right?
Yeah.
Yeah, we don't say that, oh, I'm told for like, what is it, meter. We always have this one as a positive value, right? Like the height or any measurement of the length.
Okay. Positive. So this has to be.
Yeah, so actually here to be more accurate, you don't describe those as magnitude, but those will be called like algebraic value.
One.
Algebraic
Oh, okay.
value of a vector.
Okay.
So I could add another box for algebraic values, and then I have these two arrows on it. Does it make sense?
Algebraic value and then going.
Yeah.
Okay.
So this one is inside the algebraic.
Okay.
Okay.
Yeah. So this should be algebraic.
That's very nice.
Always greater than 0.
Oh, no. Algebraic can be positive or negative, but magnitude always greater than 0.
Oh, okay.
Yeah, so you need another sticker note for magnitude.
Need another sticky note for magnitude.
Yes.
Magnitude always greater than 0. Right.
Okay.
It should be, yeah.
Yeah, this is very important when we want to solve these problems with forces. So make sure that you always remember the difference between algebraic value and the magnitude, okay?
Okay.
Good. So then continue.